Hello, this is John, W7DBO, with the Ham Radio 360 Field Radio Podcast. This is continuing our series in the VHF, UHF, GoBox build for voice and digital communications. In the first episode, we discussed the goal and the mission and project scope of this project. In the second episode, we did a rough layout of the items and a wiring diagram. In this episode, we're actually going to be manufacturing and assembling the box. The first order of business is to 3D print and manufacture all the brackets and plates for the two GoBoxes. As you can see here, we're in Tinkercad. Tinkercad is the free software program online that you can use to design items for your 3D printer. On the left here, we have the first plate, and this plate will be our patch panel plate that'll go from the radio box to the radio control head. There'll be RJ45 connector here, a 1/4 inch for the foot pedal or hand switch, auxiliary audio, audio A and audio B, and then power pole. So this will form an electronic snake that will go between the boxes and provide power to this box and the components. The radio remote control head will have its own cable. The plate on the right will have a voltmeter and also a USB power ports. There'll be an additional plate that sits in the back of the box that'll have power pole connection and a 12-volt socket connection. As you can see, I have a single bracket here. This is for a USB outlet. We'll actually print 2 of these, and these will be for our task lights that sit at the top of the box. Over on the right, there is a simple L bracket that'll be used to hold the paper clip on the lid of the box for any documents or notes. And lastly, at the bottom here, we have I'll bring this into view. This is a simple bracket that I needed to build to hold the MFJ clock in the lid of the box. Now, normally with plates in radio boxes, I don't hard print the bracketing, as you see here on the side with the screw holes. I usually do these separately, but in this case, the box was so small and there was very little room that I found it easier to go ahead and print the bracket with the faceplate. Okay, switching over here to another file. This is for the MFJ Selector Switch. I needed to build a bracketing system that could mount this inside the box and also use the top of the box as a base for the remote control head for the radio. So this is project, as you can see, this blue area is the maximum print size of my printer. So I actually had to print this in several pieces and then connect it together using bolts and screws. So over on the right here, you can see my first piece is simply a riser bracket with a screw hole to go into the box, a hole to mount to the selector switch, and then also a connecting point. Then I built my first piece and then a connecting bridge, and then once again just simply repeated the same process on the other side. And you can see how there's some inset lift there in these two products. That's where the base of the remote control head will slide in and hold. So once again, if you find limitations in your printing space on your 3D printer, this is a great trick to be able to build larger projects and just assemble them after they've been printed. Looking here at the box in a rough layout, you can see I have my 2 speakers, the remote control head, and then also the microphone selector switch. Sometimes when you're working in small boxes, it works better to set the items on top of the box and drill through the top. And then, as you can see in this photo here with the speaker brackets, and then reverse it inside and do your mounting. Here's a photo of the 2 speakers, and as you can now see a better picture of the selector switch and the 3D printed bracket that goes above it. In this photo here, I'm laying out the patch panel bracket on the side, and then in this photo you can see how it's been installed and wired up. In the back we have the power ports that just mount farther back for use, and then also you can see in this photo we're starting to get the side brackets installed, and then in this photo here we have the top USB bracket for the light. Now, when working in small boxes, it's important to have enough wire, but not too much wire. The more wire you have, the bulkier it gets. But if you go short on your wire, you create stress points where things become disconnected during transit. So here you can see I have a wiring harness built out of the Wago nut connectors. And this is my harness for powering up all the different items in the top box. Here's a photo here, the final photo of this box. Everything is laid out and all the components are in place. Before assembling the radio box, I also needed to manufacture some bracketing and panels and plates for this project. As you can see here in Tinkercad again, this is my slide bracket system that I use for the radio. These two components on the right go in the normal holes that the radio is provided for bracketing. And then these two brackets go in the box, and the bracket will slide down this channel. And I'll turn it around here so you can kind of see the channeling. So this creates a way you can slide your radio in and out easily for port changes in your wiring, or just sliding it out to let the radio breathe better when you're using a heavy duty cycle. And as you can see here in this photo, we have the radio inside the box. Now you noticed in the other print, I just printed the 3D part, and then I'm using common L brackets to secure to the box. This creates a stronger point for the brackets. Here's another photo of these L brackets put on the 3D printed plate. And then assembling the radio, putting the other bracket on the radio, and then simply they slide together. And then this creates a great slide mount system for your radio. Then once we have it in the box, everything is put together with nylon lock screws so things do not vibrate loose in transit. Okay, switching back to Tinkercad for the radio control box, we've got quite a few components here that all come together for this box. So I'll just walk through each item and how it was built. So first of all, we have the left plate. The UHF connector will go at the top. We've done some lettering that will offset in the print, and so we've printed some lettering on top of the plate. We'll change colors at a 4mm thickness, so the lettering will appear in a different color of 3D print. We have our two-way switch, so in the up position we're relying on battery, on the down position we're doing external. We have a power pole port for the external battery connection and the charger. And then on the bottom we have an additional power pole outlet. Now over in the center plate, this has got quite a few components that are unique to this radio box. The first hole is a 2 USB port. This will be for the signal link and for the radio programming. We have a 2 fuse for positive and negative, a USB power outlet, a hole for the signal link, and then this is the patch plate that I referred to earlier. So the network connection, the audio, and the power. This will be the patch point between the radio head box and the radio control box, and then another hole for more USB power. Then over on the right, we have a large hole for the SWR meter, 2 holes for 12-volt sockets, and then the last hole is for the DROC power meter that'll fit on the top. Now we have some items that have some weight to them and would not set very well on just a thin panel, mainly the SWR meter and the signal link. So if you can see this bracket up here, this bracket right here is going to be bolted in at this point here and here, and it'll actually provide an anchor point for the SWR meter. And then also the signal link is a larger item. So we have printed this separate. I'll bring it into view here if I can get it backed out. So for the signal link, have added an additional printed plate that'll have 4 mount points, and it'll provide some strength and depth to holding the signal link in place. Now for bracketing, as I mentioned before, I usually like to bracket items separately from the plate. So the pink items up here, I'll bring it down in. This is the bracket that'll go between the box and the plate, and there's anchor points there and over here. And then where they're in the middle of the box where there's no anchor points, I have these little tabs that I've printed to go to tie these two plates together. Once again, you can see the limitation of my printing platform is the blue area. And so I utilize binding plates together with other 3D printed brackets to create a larger item in a smaller print space. Lastly, we have a couple extra brackets that need to be printed. This is for the Biano Power 12 amp hour LiFePO4 battery. This bracket was originally going to hold the battery, and I normally do kind of these brackets when I put the battery in the center, but because the signal link and the radio was in the way, I actually went to this U-shaped bracket. And so we put a U-shaped bracket on each side of the box, and that secures the battery in the center of the box. Now you also see this little tab guy here, and I'll bring him down into view. This was simply used as a drilling template. So this is the exact same as this, because when I set this up against the box, I cannot get my drill past these 2 points to get a straight shot. So I just simply created a little printing template, or a little drilling template. And then once I'm done with that, I just throw this away. So as you can see here in this photo, we have the SWR meter mounted to the plate with those additional brackets. And then you can see here with the SWR meter, the bracket attached to it first and then attached to the plate. And so this created a great mounting point for the SWR meter onto the panel. Here in the radio box, I'm starting to add items in and drill them in. And as you can see here, I have a little crook neck light. This is a IKEA light. And when you're working in boxes, it definitely, you got some shadow issues and some light. So I really like having this on my desk and using it to light up the inside of the box as I'm working. You can see here we have the radio mounted into the box. And then here's our bottom plate as we put on as many items as we can before bracketing it in. And here's the back shot of that signal link bracket that just adds depth to this panel to support the signal link, as you can see in this photo. And this signal link can slide in and out because you might need to configure the pin set inside the signal link. As you can see here, this is where the Biano Power battery is going to mount, and you can see those U-shaped brackets that have been put in on each side. These brackets have been printed at 100% density to add strength to holding the brackets. The issue is with batteries is you never want to obviously drill into them for mounting. So you need to find ways to mount the battery in the box without drilling obviously into the battery. And so the 3D printed brackets is a great way to do this. And then sometimes I'll back it up with some Velcro strapping or nylon strapping to hold the battery in place. As you can see here, we have the final product of the box and everything fit in. And once again, when working with boxes, I always highly recommend leave a lot of room. First of all, for the radio to breathe. Second of all, things take up much more space than you realize when you get into tight situations with the box. So always plan for extra space around items for the bulkiness of the item and the connectors and the wiring. And I selected this deep box from MTM because I wanted to be able to use the top tray to hold wires, as you can see here. So my panels are deep set in the box. And because the box was the extra deep box, it allowed that. So I've now created the snake between the two boxes carrying the power RJ45 connection and the two audio connections. And I used wire cable sleeving, this is 1/2 inch, to be able to hold all the items in a nice snake type format. So here's the final product for the radio control box. This box will sit on the table, and as you can see, the MFJ clock, the notepads, and everything is assembled and powered up with USB lights. Overall, this was a very satisfying project. Like I stated in the beginning, I have built many boxes for many people, and I've gone through many iterations myself with this radio, but I feel like I've finally come across the perfect solution for me in the fact that I can have the radio box sitting under my desk at home or in the field, and then I can take the parts of the box that I do need quite frequently in the top box and set that on the table to save space. And so as you can see here, this is a photo of this system being deployed in the field. And in the next episode, I will give a full field report of this box and how I was able to use it at a aid station for a backcountry ultra run. I hope you enjoyed watching this video on building this GoBox. As always, please email me at john@hamradio360.com with any questions or comments. And if you like these videos, please be sure to subscribe. If you have not heard of my podcast, the Ham Radio 360 Field Radio Podcast, you can go to fieldradiopodcast.org to find out more information and subscribe to the podcast. This is John, W7DBO with the Field Radio Podcast. Thank you for watching 73.